Thank you everyone for joining us today from all around the world. We're glad that you're a part of session 2 of our series, and we are excited to get started. So go ahead, Ed, if you can switch the slide for me. Again, would like to thank you all for joining us today, along with our international partners. We have, our partners are LearnFast from Australia, based in Australia, Stronger Brains, based here in California, Brain Maps, based in Shanghai, and Brain Fit, that is based in Singapore. But again, they cover a variety of areas, and we work closely with them on this series, as well as other things, services and products that we provide. So thank you again. I'd like to introduce our panel today, and they will be helping with questions and discussion at the end. And Ed, if you can go to the next slide, we can share our panelists. We have Alex Kitts, who's here in California, and he's a clinical psychologist and co-founder of Stronger Brains. We have Cheryl Chia, who's a physiotherapist and founder of Singapore-based Brain Fit. And we have Dave Stanley, who is the Director of Learning Ecosystems at LearnFast Australia. Also want to let you know who's answering the questions today too is Steve Miller and Tom Nugent, who are the co-founders of Elite Performance Solutions. We appreciate them joining us. I'd now like to introduce our presenter, Ed Hamlin. Ed is the founder and clinical director of the Center for the Advancement of Human Potential. Ed, if you can go ahead and go to the next slide. He obtained his doctoral degree in clinical psychology from the University of North Carolina and taught at UNC and Duke University before moving to Asheville. He's certified in EEG biofeedback by the Biofeedback Certification International Alliance and a member of the American Psychological Association and the Association of Applied Psychophysiology and Biofeedback. So we're so glad he's here today to present to you. So we'll go ahead and get started with our session today. And Ed, you can go ahead and go on the next slide.
Thanks, Kim. I'd like to thank the folks at Elite Performance Solutions and their partners for inviting me to do this. And I want to thank you, all of you, for being here with us this morning. I've been looking forward to this. If you've been paying attention at all, you know the brain is the rage. Now there's neuroeconomics and neuroeducation, and everything you pick up, every magazine you pick up just about will have some article about the brain in it. And so it's an exciting time in the field of neuroscience with lots of discoveries going on, and you keep reading about the discoveries. But it's interesting when you begin to think about applying those studies and what they mean and how they can be put into utilization. So one of the things we know about the brain is it's an electrochemical organ. And so the electrical aspect of the brain and the chemical aspect of the brain are intimately related, because the chemicals get released due to action potentials that occur within the brain cell. So when the brain cell reaches a certain electrical potential, it fires a signal off that results in releasing of neurotransmitters. So these have always been connected, but there's been a lot more emphasis on the chemical part of it, the soup of the brain, as it's referred to. There's been a lot more emphasis on that for the development of medications and such. So there have been, for decades now, there's also been people who've been focused on the electrical aspects of it, and those are the kind of things we want to talk about during today's session. So there is this electrical output that's easy to access and easy to measure compared to the chemistry of the brain. The chemistry of the brain is difficult to measure. You have to assay the tissue, and that requires removing it from the brain to be able to do that. But we can actually measure the electrical activity of the brain relatively easily because of the EEG signal that it produces. So this is what an EEG looks like. Up here in the upper corner, you see the locations. So this is the signal that's obtained at each one of these locations. And in this display, the top signals up here in the front of the head, and the signals back here at the bottom of the display or at the back of the head. And so this is the fluctuations in electrical activity that's produced in different areas of the brain. So when you talk about this, you can measure it in a couple of ways. We measure the frequency and we measure the amplitude. The frequency is the speed of fluctuations, the speed of brain cells firing in the brain. And so if this is 1 second, if the distance between these two lines is 1 second, you can go up here and count the peaks that occur between those two lines. There's 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8 cycles per second, or 8 hertz. And if you look at where that 8 hertz occurs in the spectrum of all these different activities, you can begin to classify the speed from slow to fast. Then we measure the power of those signals. That's measured in voltage, but since it's very small, it's microvolts. But that's really the height of the wave. So back here, we measure this, and it measures at 10 hertz. And when we come back here, you see that it's bigger, and so we measure that at 20 hertz. So this combination, 20 microvolts, this combination of frequency and amplitude is what tells you the arousal state of the brain. So this is the full spectrum of this. So delta are the very slowest waves. They have very few peaks, and they tend to be very large in amplitude. So the power of that tends to be high. And then theta is the state just above the delta state. Delta is associated with sleep. This is what your brain is producing when you're sound asleep, not dreaming. Dreamless sleep displays in delta waves predominantly. Theta is drowsiness and imaging and daydream. So if you're dozing off, you're creating theta waves. But also, if you're just picturing something in your head, you're creating theta waves. So the theta waves. And so this is the slightly higher, but your focus is internally in what you're internally generating rather than the external environment. Alpha waves are what meditators tend to produce a lot of. It's kind of an idling state. It sort of straddles the internal and the external. So you're aware of what's going on internally, but you're also aware of what's going on around you. It would be hard to sneak up on someone who had their eyes open and were producing alpha because they would see you coming. If they had their eyes open and they're in a theta state, you might sneak up on them and they might startle if you spoke their name or things like that, because they're not monitoring the surrounding environment as well. But the folks with alpha waves are doing both. They're sort of aware of what's going on inside of them, but also aware of what's going on outside of them. Beta waves are the faster waves. So you notice the amplitude is getting smaller as the brain becomes more active. And so the beta waves, it's hard to count the peaks because there's so many of them between the circles. So they're above 13. And the amplitude is relatively low because when the brain is in an active state, focusing on an external task, you have different areas of the brain doing a variety of different things, visually processing, associating with things you already know, making the connections between how this is relevant and what you're going to do in relation to it. So you've got different areas of the brain doing different things, and it's very busy. So a lot more activation during that when you're in a beta state. So through the miracles of electronic filters and digital processors, we can take the raw signal, this raw signal that's up here, which is really composed of different amounts of all of the frequency spectrum. It has this is beta. This is a beta state up here. It's kind of hard to count the peaks in the time frame that's up there. So this would be a beta state. But even in a beta state, you have certain amounts of delta, theta, alpha, and even the faster frequencies above beta. You have gamma and other frequencies that are there. With electronic filters, you can actually determine the proportions. So these are the amplitudes of this frequency range. So you can measure how much contribution there is from all of the frequencies into the raw signal that's being obtained. And you all remember this, you've seen this before, I'm sure. This is the Yerkes-Dodson arousal performance curve. And what this says is as arousal increases, your performance will increase to a certain point. And then as arousal continues increasing, your performance begins to decline. And so this was established back early in the 1900s and primarily was involved with learning, but it turns out it applies to free throw shooting and lots of other things besides just learning as well. And so if you take this, if you think about applying on arousal across the EEG spectrum of frequencies, this is a low level of arousal and this is a high level of arousal. And where you fall primarily on this spectrum kind of determines how efficiently you are at performing the task. And so you want to generally be in your waking state, you generally want to spend most of your time in the middle ranges of the spectrum. So somewhere between alpha, low beta, and mid beta for most tasks that you would be involved in doing. So when we look at this in terms of the raw EEG signal, if you're doing an external task, something that requires you to focus on material in front of you in the environment, what the teacher's writing on the board, when you're reading, this is the level of activity that you would kind of expect to see. These two people, this was recorded from two people doing the exact same thing. They were doing a biofeedback task and they were focusing on the information that was being given. So both were doing the exact same task. And this is someone who was focused on the information, understanding what the information was saying and noticing what effect they could have on it. This is someone who has a lot of slower frequency activity in their EEG. You can see how it's so much easier to see the peaks in this. So that means they have a lot more slow frequency activity in their signal, which remember this is theta wave activity, which is a high state of internal focus. So this is someone who's paying a lot more attention to things that are going on inside their head than they are the things that are in front of them in the environment. So once that knowledge was put together, then we figured out maybe we can train these things. They had a lot of, in the 1960s, there was a lot of effort being put into physiological biofeedback, and people were learning you could control your muscle tension. You could control your heart rate. You could learn to control your blood pressure. There were lots of things that you could learn to control. And you did this through this biofeedback process. You took a measurement of some physiological process that was fed into a biofeedback device, something that could take that signal and convert it into either an audio or visual display that could be fed back to the person. So in this process, you're measuring, it could be heart rate, it could be muscle tension, If you fed that through a device that can convert it into either a number, a bar that went up and down, a tone that increased or decreased in pitch, all sorts of audio-visual displays, that the person could learn that they could either increase their skin temperature, decrease their muscle tension, or they could learn to take it in the opposite direction. But it was something that could be learned. You could learn to control your own body. So there were people in the late 1960s that got curious as, could you do this with EEG? And so they started using EEG as the measurement and feeding that through the devices. And it turned out that that could be done. So there was a paper published in the late 1960s about the operant conditioning of the EEG. So that led to the development of the field of neurofeedback. So neurofeedback uses real-time EEG signals that are being acquired as they're being produced, because they fluctuate very quickly compared to things like your skin temperature or things. So the real-time aspect of it becomes important because it comes and goes rather rapidly. So it started being employed in the 1960s. The very first application of it was for the treatment of epilepsy. And that was actually what got my attention, got me interested in becoming involved in this. But it was very quickly discovered that it had applications outside of epilepsy. And the very next thing that was that it was used for clinically was for the treatment of ADHD, to help improve focus, reduce impulse control, and enhance executive functioning. So for proponents of neurofeedback, people like me, the demonstrated benefits are twofold. One is that you can measure and train these EEG signals, and that the brainwave improvements lead to behavioral improvements. So when an individual learns to be able to regulate their brain, it usually results in better performance regulation, emotion regulation, cognitive functioning, and other benefits. And those benefits remain beyond the training, so they persist. So when someone is doing neurofeedback, this is the process that you see. There's signals being obtained. EEG is being measured. Here it's being converted through a biofeedback device. So it's measuring the different frequencies, the amplitude of the different frequency bands that are there, with the goal of increasing some of those and decreasing others. That's being displayed to the person who, in this particular case, looks like they're probably trying to levitate Buddha over here, that they're trying to raise Buddha up in the air. And so as they do that, they're getting their these different EEG bandwidths, the slow frequency, the middle frequencies, and the faster frequencies. They're getting them into the range that is beneficial for functioning. So they don't have to know anything about what's going on with their brainwaves. All they have to know is the goal is to get Buddha to levitate, and so they work to produce that. So as they are better able to control their brainwaves, as they make these proportions more ideal for focus, for attending, you get improvement in concentration, attention, and cognition. So if you've been paying attention to any of the neurofeedback literature, you may have heard someone say there's really not very many studies out there regarding neurofeedback. I run into that a lot when I'm talking about neurofeedback in other settings. So I looked in earlier this month. I looked at the National Library of Medicine and did a search, and there were almost 2,400. It was 23,094 or something like that, almost 2,400 studies on neurofeedback or EEG biofeedback. And about a third of those studies were regarding ADHD. The National Library of Medicine has particular criteria for what they include. So there are lots of things they don't include, but they have to have peer review for publication and lots of things. So I did the same search in Google Scholar, and there were over 3,700 studies of EEG biofeedback. And again, about a third of those studies were regarding ADHD. So ADHD is something that has been studied pretty extensively within this literature, much more so than most other conditions. So these are studies that have looked at the efficacy of ADHD, of some of those many, many studies that have been done, but these are kind of key ones that are generally pointed to. Way back in 2002, Vince Monastra and his colleagues are the first people that really demonstrated sufficiently demonstrated, it had been reported previously, but they were actually demonstrated that the benefits followed cessation of treatment for neurofeedback, but they didn't persist for the medication. So you got benefits from the medication while you were using the medication. When you stopped using the medication, you went back to baseline. For the neurofeedback, when you stopped the neurofeedback, the gains persisted. And so that was the demonstration of that. Levosque and Levosque colleagues in Montreal, they showed pre-post fMRI changes after neurofeedback training. So they were training people who were diagnosed with ADHD, and they were actually doing an attention task while they were imaging them, and the people that did neurofeedback training showed changes in their brain functioning persisting after their training was occurred. But this was the first study that showed fMRI changes, and fMRI still kind of serves as the gold standard for brain change measurement. And Gavin Slavin and their group in 2009, they actually compared neurofeedback to an active control, so that they were using computerized attention training task, and showed a beneficial preference for neurofeedback, and the benefits of that lasted at least 6 months. They did a 6-month follow-up and 6 months post-training. So these are studies that showed the lasting benefit. It showed the brain structure changes, brain functioning changes, and they showed its preference over other attention training tasks that were being used. This is a study that was published last year that compared neurofeedback to several other modalities, and there's a lot of information in this that I won't spend time going over. But this used criteria established by the American Psychological Association for efficacy studies that was tightened up in the 90s, and then was even strengthened again in the 2000s. So they started looking at effect size, because, for instance, if like Barry Sturman was the person who was using neurofeedback for epilepsy, his idea was, if you had a large enough sample, you could reduce someone's number of seizures by 5%, and it might be significant, statistically significant, but it wouldn't be clinically that much of a benefit for the person. So you start looking at effect size. How much difference does it make? And for Barry established the idea that, this was before this criteria was in effect, but Barry established the idea that it had to reduce the seizures by at least 50% before it would be kind of clinically meaningful. This standardized the statistics of that. And so this line here that you see that has the L after it, this line is a large effect. This is a large effect size. So this line starts this. These studies on the left side of this were multi-center studies. So these are larger studies. They have hundreds of subjects in them, and they were done in a variety of centers. And they were using neurofeedback. They were using different types of neurofeedback in their training. And so these are not all the same type of neurofeedback that was being done. The lighter shaded line is looking at pre-post. The darker shaded line is looking at pre and then a follow-up period afterwards. So for most of these studies, you actually see that there was not only continued benefit, but there might have been an increase in benefit, because as you begin to be able to focus better, that actually becomes its own feedback loop. So you continue to see benefits. In this study that was done, they didn't reach the large effect size. This is a medium effect size that they reach here immediately following training. But after their follow-up period, now they're above a large effect size. So this one actually showed a big change in this. The last one really stayed in the medium range. So when you look at this, all of these effect sizes are medium to large for neurofeedback. This is the very large National Institutes of Mental Health funded study looking at, particularly at ADHD, and looking at combined medication and behavioral training, looking at medication alone, looking at behavioral training alone, and looking at community treatment. So these people were just seeing folks in the community. Many of them were taking medication, many of them were getting educational training, many of them, their parents may have been getting parent skills training. They were just whatever was available in the community. It wasn't a controlled group. So treatment as usual for this group. And so you see this very large effect for the combination of medication and behavioral treatment. It drops off at follow-up. After this, the medication in this study was being done by an algorithm. So it wasn't like in the community where different providers might have different standards. The medication was being prescribed and the behavioral treatment was being prescribed. So you see very large effects for those. For the behavioral treatment alone, again, it's a large effect size. And for the community treatment, it's a large effect size. It exceeds that. There's a little bit of a reporter bias that comes into this because they're using parent and teacher reports. And so when you use medication, the effect is pretty immediate. It's a very quick effect. And so you're much more likely to notice and report a quick effect than you are something that's more gradual. Neurofeedback is a gradual learning procedure. And so there may be small incremental shifts that aren't as noticeable. So there's a little bit of a bias towards something that's going to have a rapid change in someone's behavior. But nonetheless, this still remains. Obviously, these remain pretty powerful because medication is often very often the treatment of choice for these conditions. These are neurofeedback studies that were done in a single clinic. So these were done in a single clinic, and they weren't done in the same way that these studies were done, where there was a neurofeedback protocol that was being applied. These were neurofeedback protocols being applied, but the people in the clinic were doing other things. They were seeing these folks as clients, and so they were bringing all their resources together for them. And in this case, you see these results start approaching the results of the MTA study. The last study mentioned here is a large international study that was done, and it really is the treatment as usual, looking at medication as it's applied. This is particularly a medication outcome study, but it was done in the community where the people would have been doing things besides just medication in many cases, so it was a treatment as usual. And so you see that the effectiveness is pretty good for all of these different approaches to things. And at least the neurofeedback is reaching this, but it does look like in actual clinical application that when you combine this with other approaches, you reach higher effects than you would otherwise. So this was the conclusion of the meta-analysis. And oh, I didn't mention the remission rates. The remission rates here, the percentages that are up at the top of the graph, these are when after treatment the person would no longer meet criteria for the diagnosis. So this is when the symptoms have been reduced to a level that they would no longer meet diagnostic criteria. So in the neurofeedback studies, that's 32 to 47%. The medication reached a 68%, the combination reached 56%. Other approaches were down in the level of the, and below the level of neurofeedback. This is the only study that actually reported the remission rate. It was at 53%, which is pretty close here. The study of the medication applied in the community is actually lower than the study that was the study where it was tightly controlled. So just left to various practitioners, it's actually in the range similar to the neurofeedback. So the conclusion of the meta-analysis was that neurofeedback produces a medium to large effect with a 32 to 47% remission rates, and with sustained effects 6 to 12 months. There were varying ranges of the follow-up studies, but 6 to 12 months after you stop training. So this is where it brings the whole idea of arousal, attention, and EEG biofeedback together. They all converge, and that's I like to think of that as the sweet spot. So as you begin to improve the ratios of the different frequency bands, as you learn to be able to control that and experience the enhancement of focus and self-control that comes from it, it feeds into the other aspects of functioning. I do think there are some significant limitations to neurofeedback that we have to realize. One is it's not always locally available. In the United States, there are sometimes large distances between neurofeedback providers, and so it's not practical for a lot of people. Not all approaches to neurofeedback have been shown to be effective. That doesn't mean they may not be effective, but they haven't been demonstrated to be effective. And as you think back about that graph where there were different types of neurofeedback being done, they had different rates of remission and different rates of effectiveness. So some weren't as effective as others. This kind of training is usually done by a single practitioner in an office setting, so the number of appointments that are available is limited. And they may not be available at convenient times. It's in our clinic, sometimes they have to choose between soccer practice and neurofeedback sessions, and most of the kids would prefer to go to soccer practice than come to neurofeedback sessions, so it may affect their attitude that are there. The cost can be prohibitive. It costs a lot to buy the equipment sometimes to do neurofeedback. It costs a lot to get trained to do it. And so you have to recoup that. And in the United States, it's generally not covered by insurance. So it becomes an out-of-pocket expense. So it can be extremely high. And then the transfer to real-world activities doesn't always occur. So somebody could actually get pretty good at doing neurofeedback, but not be able to apply it to situations outside of the neurofeedback training session. So that led to some ideas that I got to put into a chapter in Using Technology in Mental Health Practice, a publication of the American Psychological Association. It's actually intended as a textbook. That I was speculating about the future of neurofeedback, and I really think that as we begin to lower the cost and lower the burden, it's going to be available to more people. So there are devices that are being produced that are inexpensive but reasonably high quality. That was going to be a necessary change for broadening the application of neurofeedback, and they're becoming available. So there's some things listed here that are there. This a lower cost device that each person can have access to outside of a clinical office setting permits a greater frequency of training. So one of the things we know about most learning things is frequency, intensity, and duration of training sessions has an effect on the outcomes. And so this would allow for greater frequency of use when you're not tying up a clinician's appointment times, that multiple people could be doing the training at the same time. And when you can do the training in real world situations, it helps with the transfer of learning. So when the training can be done with a real world activity instead of making Buddha levitate, if you could do this with a task. And so for a while, I used to do a homework group for students. They would come in, there would be 6 or 8 of them. I would hook them all up to EEG neurofeedback equipment, and they would do their homework. So then they could come in and spend an hour in the clinic and be finished with their homework often when they were done while they were doing their training, and it helped with transfer. So this real world activity was is going to be important in it. So I want to thank you for your attention. Your secrets are all safe with me because I zoned out about 30 minutes ago, and probably that might have been the case for you because we have a lot of things vying for our attention. So I appreciate your attention, and we can turn this over for some discussion and questions now.
Thank you so much, Ed. We appreciate it. Yes, any questions from our panel?
I have one.
Ed, Alex, if I can, Ed, great talk and introduction for us on the EEG, and you joined some dots for me in my thinking. A couple of families I've spoken to over time have mentioned the fatigue that their kids have had from several sessions of neurofeedback. Is there a way to minimize that fatigue? Is there an optimum length of time for kids to be training, that ratio of how many days a week, how long is each session? Yeah. What's the balancing act?
There is, and there's actually information in the EEG that tells you this person's pooping out now, and if you continue training, they're just going to get worse. And so there are ways of doing that. And one of the things is, of course, with computers, you can begin to use that information as you begin to see the ratios begin to shift from active to fatigue. As you begin to see that, it's better to stop the session soon after that. So instead of doing a prescribed period of time, like having someone come in and do 30 minutes of training, if they poop out, which they will if they're having to exert increased effort, put more energy into it, if they poop out at 15 minutes and you continue to train them 15 more minutes after that, it's probably not going to be perceived as a rewarding experience. So I think that actually interferes with learning. So with computers, you can actually turn that into an algorithm so that you can help maximize the amount of time the training's effective. And then over time, you would see that increase. So there's focus and then there's concentration. So the focus is the intensity of the focus in the moment, and then being able to sustain that over time. So that's what we typically see. If someone comes in, they may be able to train productively for 12 minutes initially, may not be that much, but let's say they can train 12 minutes eventually. Within a short period of time, then you should be able to see them increasing that to 15 minutes, and then 18 minutes, and then and so on. So absolutely, but it should be a little bit tiring. It's like going to the gym and lifting weights. If you go, you lift some weights and you begin to fatigue. That's what it should be. It should be effortful. There should be an effort involved in it. And then what you're doing is being able to strengthen the effort that the person can bring. Great
Excellent.
question.
When you said focus there, is that also a function of the level of interest? You mentioned having them engaged in real world tasks allows for better transfer. Does that mean keeping the real world tasks that the kids have, or the patient has more of an interest in, will help reduce that fatigue, sustain that focus and concentration for longer?
It will, but that may not be as beneficial to them as learning to pay effortful attention to something that isn't intrinsically like their homework. They probably would rather be playing a video game that appeals to their capturing their interest. It appeals to bright, fast-moving explosions and novelty and bright colors. The math homework may be a little less inherently interesting to them, but that will be what's important. So a lot of times when a child comes in and or an adult, they come in, they first start doing neurofeedback. It's new, novel, and interesting to them. The third or fourth time they come in, they've seen Buddha levitate, so it's not quite as interesting to them anymore, and they'll say, "This is boring." And I'll often say, well, good. Now the training really begins.
Now the effort starts. Yeah.
So, yeah.
That makes sense. Thank you. Thank you very much. Sorry, Alex. Over to you.
Ed, wonderful presentation. Wonderful presentation. A couple questions. One, how do you understand that one study where neurofeedback was compared to an active control group doing computer-based attention? Because it would seem that if they're engaged in the active control group, they are, in a certain sense, modulating their brain waves.
Absolutely, and both groups benefited. When we did a study for a graduate thesis several years ago. One of my students took college-age students that were diagnosed with ADHD, none of which were taking medicine at the time of the study, and we did a single-blind study where we used muscle tension, relaxation training, and neurofeedback. The subjects didn't know which was driving the feedback they were seeing. So in one case, we were just teaching them to relax their muscles. In the other, we were actually teaching them to focus, training their brainwaves. At the end of the study, both groups improved. The group that trained their focus improved significantly more than the group. So the training was going on in paying attention to the feedback. There was some degree of training that was actually occurring from doing that. And so that was the case in the active training group. They actually looked better, but there was a significant effect for the neurofeedback over the computerized attention training.
How do you understand that?
Well, I think if we looked at their EEG, the group that did the computerized attention training was making changes in their EEG. The improvement was related to changes in their EEG. But training the EEG directly instead of indirectly kind of gave them more information about when they were becoming more focused, whereas the computerized attention training didn't give them that feedback. So it was the difference was in the feedback.
Huh. Thank you. Thank you.
Sure.
Ed, so we have a variety of good questions. One of them is, I'm going to ask that maybe offline or to the audience, we can maybe share a copy or at least a link to that article, the chapter you wrote.
Sure.
Because we got a lot of questions about what electrical wave targets, and the question I had connects back to something that Dr. Rabner said last week, and that was about the inattention versus the hyperkinetic.
Mm-hmm.
So he had made a point that the medication really helps the movement and hyperactivity element,
Right.
not as much the inattention.
Right.
And again, not your fault, but some of the studies that you mentioned didn't separate that out.
Right.
Do you want to, can you comment on that more, or give us some insight as to whether there's a, in that chasm, is there a split between how EEG helps, and are there different targets for the hyperactivity versus the inattention one? Because the inattention one seems to be the one that's not as easy to change.
Right. And that's actually, these studies don't generally separate that out, but if you look at the data, if you actually go in and look at the data, it's just the opposite from the medication. The medication has a greater effect on the hyperactivity component of ADHD. The neurofeedback has a greater effect on the attention component. They both have effects. I mean, there is an improvement in attention, but the decrease in hyperactivity is greater for the medication. You do get a decrease in the hyperactivity with neurofeedback, but you get a greater effect on improved attention for that. So the study that I mentioned about the fMRI, the change that was noticed from doing neurofeedback, the actual changes were in the inhibitory mechanisms. So that's where the improvement in hyperactivity comes, is the improvement in the inhibitory effects. And you can adjust training to focus more on one of those aspects than the other, because you see a lot of folks they really don't have the hyperactive component. They just have the attention component. The training you would do with that person would be different from the person who has more of a hyperactive component. So you can adjust the neurofeedback training to focus more on that. One of the studies I didn't mention was a study that everybody was taking medication. It was also a study done by Vince Benastra. Every subject was taking medication. They were diagnosed with ADHD and they were taking medication. So they trained them for the school year. They trained them twice a week for the school year, essentially. And at the end of the school year, they stopped the medication and they stopped the neurofeedback treatment. And this is the study that led to the one that was that I mentioned. When they stopped the medication, all the benefits that the person was displaying went back to baseline. When they stopped the medication and the neurofeedback, the people that had medication and neurofeedback, their benefits remained. And so the idea from that was beneficial for us, because prior to that study, I used to make people choose between medication and neurofeedback, because I worried that the people doing neurofeedback while they were taking medication, it would be a state-specific learning and it might not transfer. But after Vince did the study demonstrating that even training with medication, so a lot of times we will get the benefit of the medication, which helps the person be able to sit still and train longer. And then at the end of that training period, when we've got the neurofeedback, more neurofeedback sessions done, then they're less hyperactive than they were before.
Thank you.
Thank you, Ed. I thought you made what I always felt, it's a very complex topic, really easy to understand.
Oh, good.
I have two questions. How old would a child be before you would recommend neurofeedback as an intervention? And the other question pertains to mindfulness training. Would you kind of think of it as a layperson's version of neurofeedback training almost? You know what I mean? You're trying to get to a certain state in the mind. Yeah, I'd like to hear your opinions on that.
Yeah. The youngest that we do in our clinic is 4 years old. And there are clinics though that train younger kids. My problem with doing that is I'm not sure what's typical. Below 4, I'm not sure what's typical, so I'm not sure what my target is. For 4 and above, I have a pretty good idea of what the target is. Below that, there's just too much variability and not much data about how you could expect it to look. So we start at 4, and there are people who will call and they'll be counting the days until their child turns 4 because we apply that. The idea of mindfulness training is some of the changes that you see from neurofeedback training are very similar to the changes that you see with mindfulness practitioners, but it compresses the time frame, so you can learn it quicker. I actually do some consulting work with some monasteries, some Buddhist monasteries about this, and they have reported an enhancement of their meditation practice after they've learned neurofeedback. So I actually think the feedback of information amplifies and speeds up the learning process. So I think of this as kind of a high-tech mindfulness practice, and for the focus training aspect of it.
Thank you. Any other questions coming through? Tom and Steve, anything else coming through on the Q&A?
I definitely do, but I figured I'd give other people a chance. It's not a strength of mine. So.
And again, those of you raising your hand, due to the size of the group, we won't be able to respond to a raised hand, but please type your questions into the Q&A. And if we do not respond within the session, we will get back to you later on.
Yeah, so Tom's answering questions, written questions. And so I'll throw in another one that I know that we both had because they're populating up. So 2 separate issues. One is issues regarding using neurofeedback with kids with autism.
Mm-hmm.
And then the other question was not specific to autism, but in general, what would be a concern if I am a parent, but if I put my child into neurofeedback, or if I'm personally in neurofeedback, what would be side effects that I might want to worry about or be concerned about with a particular condition or medication or something about me where I might be like, what am I looking for if I'm worried that it's not going well?
Okay, let me do the last one. The last one first. Anything that can produce benefit can probably produce harm if it has an effect. This was a cruel study, but with the seizure disorder folks, they actually trained them with the protocol that was discovered to reduce seizures. And then it was an ABA design. Then they tracked their seizures and it reduced their seizures. Then they did the opposite. They actually trained the reverse of the thing that was shown to be beneficial, and the seizures increased in frequency. Then they trained them with the seizure reducing protocol again and reduced them. So that would have been a hard study for me to have participated in. But so you can do the wrong thing. You could actually train someone to be less attentive, if you change the ratios. And this is why looking at those studies that use different approaches, they didn't all have the same idea. The other thing was something that Dave mentioned, is I think a lot of times the adverse effects can be a result of overtraining more so than the wrong training. So if you keep training after someone is becoming fatigued, there certainly won't be the same experience of reward. So operant conditioning means you are rewarding or reinforcing the desired behavior. So if they stop producing the desired behavior and they stay there, it actually becomes kind of punishing in a way. And so you can get a negative effect from that. Again, that's why it's important to kind of watch, or at least have built in the system certain algorithms that won't be pushing the person beyond their capabilities to the level that it becomes non-reinforcing for them, non-rewarding. And remind me your first question.
It was just about the application.
Other conditions.
Yeah, other conditions, and specifically, we've had a lot of questions about individuals who have children or know people with autism spectrum disorder.
Yeah, neurofeedback has certainly been used with autism. Rob Coben and Larry Hirschberg at Brown University have done the most work that's been done on autism. You train it differently than you would training focus in someone. You actually tend to start in the back of the head instead of the front of the head in terms of placement for the training and the brain waves that you're monitoring. But it's certainly shown to have a beneficial impact. The studies on autism look good. I've spent probably the last 10 years looking at neurofeedback training for children that had early neglect and abuse or trauma, and were very dysregulated. And one of the things that we published 3 articles in this. One of the things we found is when you added neurofeedback, not replaced other treatment, but when you added neurofeedback, you started seeing much more rapid symptom improvement in those folks. They became much more amenable to the other treatments that they were undergoing. So with lots of other conditions, you don't train the same way that you would train someone for enhanced focus and impulse control, but they do respond to the training.
Great.
Can I throw a question in?
Yeah,
we've got a minute or 2 left.
Yeah, one more, yeah.
On behalf of a lot of teachers out there that they have groups of students, you've spoken several times about clinical settings. I've inferred from that one-on-one. How would I, as an educator with a group of students, get leverage on my time and be able to help those students get that neurofeedback in a group setting, whether the group was 2, 5, 10, 20, I don't know what the practical limits are of that.
Yeah, we've done some projects where we put the neurofeedback in the school so that they didn't have to come after school to do things after they've been sitting and attempting to pay attention all day long. To then it seems like punishment to have
it's already
to go
the fatigue there.
And do it again. So what we did is we put systems in the learning lab at the school, and so several students would come at one time, and so it just the limits are based on how many people you have to connect, get the systems connected. This is where I think some of the personal use devices that can be employed would really expand the numbers, because it reduces the cost significantly, but it also, the individual can put the equipment on themselves. They don't need someone to come and measure and prepare and do all the attachments that have to be done. You could come in and put them on yourself. So I think the technology is reaching a point where it can actually be used with very large numbers of people. Dr. Hirschberg, when mentioning the autism, he has such a large caseload that he always trained in groups. And these were autistic children that he was training in groups. And so he would have 6 or 8 at a time that would be in one large room doing training. So even in a population that might be, might think that it would be challenging to do this, he was able to do it. So I think it lends itself to large numbers of people doing it simultaneously.
Great, really appreciate that. Thank you.
Sure.
Thank you. Well, we are at time. Again, if you want to keep putting your questions in, you can. Ed, if you can please go to the next slide.
Kim, can you just add where we'll be making the answers to those questions available for people?
Where will we be? We'll be emailing that. We'll be emailing folks and posting those.
Yeah, that's my assumption.
Yes.
Yeah. So
yes, yeah. So we will. Yeah, we'll definitely be responding to all of you who have registered as well as who have attended today. So yes, to make the recording as well as the answers to the questions, the Q&A available. Absolutely. Again, just want to point out, thank our partners. You know, Elite Performance Solutions provides our software and services through our partners. So again, we thank them for not only partnering with us, but being a part of our panel today. So again, LearnFast from Australia, BrainFit based in Singapore, Brain Maps based in Shanghai, and then Stronger Brains based here in California. So thank you so much for joining us and partnering with us. Also on the next slide, just want to thank all of you for joining us all around the world. I know it's a variety of times that you joined us in your day. And if you can, please join us next week, either February 3rd or 4th, wherever you are in the world, for Neuroscience, the Importance of Understanding the Brain with Mike Merzenich. And we hope to see you again next week. But thank you for joining us and for your time.
Thank you very much.
Thank you so much, Ed.
thanks, Ed.
Thanks, Ed.
And next
Thanks,
week's
Ed.
next week's talk is a not to be missed talk. Sure. I'll even get up early for it.
Yeah.
Thank you. Thanks again, everyone. Enjoy your day or evening. Thank you. Bye-bye.
Bye.
Thanks, Kim.
Thanks, Kim.